Thank you. It's a pleasure to be here with you today. Get to talk to you about something I feel very strongly about. I really don't like public speaking, but I feel strongly about this. So I was willing to volunteer and be here because I think I'm going to say some things today that might help and that definitely need to be said. First of all, because I'm here representing Autoliv, I wanted to just tell you a little bit about the company. We have 5 facilities here in Utah, and we have 18 facilities here in North America that I have responsibility for, and we're a pretty big company. We have, as you can see there, $7.2 billion in sales, Fortune 500 company. All over the world, and big company. This are the things that we produce at Autoliv, the safety systems for your car. Here in Utah, we primarily just produce airbag inflators and cushions that go along with those inflators and the modules. So that's what we do here in Utah primarily. Who are our customers? Just about every major car manufacturer, well, all major car manufacturers, just about everybody. You can see here from this slide that we pretty much support all the automotive industry. All right, bottom line up front. Reduce, reuse, and recycle are each important, but not of equal value. I'm going to go into some detail about my job and the things that I have learned and share some experiences with you. First of all, I put this slide up because I love it. This is sitting on my desk, and it's a slide. I know you can't read it very well. It did the best I could with taking the picture, so let me just read it for you. It says, Leonard, Barton, keep us out of jail, Dave. That was my mission statement, and quite frankly, that's kind of the way we did. You know, that was my job. As an environmental engineer for Autoliv, I pretty much just had to keep everybody out of jail, and I was succeeding doing my job. About 20 years ago is when I started doing that, and basically what I do is watch the back door, see what they were taking out of the back door at our facility, and I would make sure that we disposed of it in compliance with federal, state, and local regulations, just like the MSDS says. That was my job. If I was really hustling and I got caught up, I could take a closer look at it, see what it was, and say, hey, why aren't we recycling this? I want to start recycling this. But it wasn't expected of me at the time. It was just, as long as I disposed of it properly, kept my boss out of jail, I was doing my job. And so over the years, things have changed. Things have really changed, gotten a lot better. And pretty soon I got to watch the front door too and see what was coming in, and I could say, hey, stop, you can't bring that stuff in here. I felt empowered. I was able to make improvements that really mattered. And I actually got people to help me. We got ISO 14001 certified, the worldwide environmental standard. We got teams inside the facilities looking at what was coming in the building, helping me do the reduce, reuse, and recycle. I mean, in the early days, I hadn't even heard of the 3 R's, and you know, that was my job. But anyway, so things have changed. Things got a lot better, and I think I really understand the reduce, reuse, and recycle, and I've learned a couple lessons about that I want to share with you today. One little thing that happened was just not too long ago, we came up with a really good environmental idea to use some heat created by some air compressors, and we wanted to use it to heat the building. And the payback was 10 years. Return on investment, 10 years to pay for it. And I thought, well, this is such a good idea. I'm going to talk to my boss. And I went to the human resources vice president and said, you know, it'd sure be nice if I had some money to spend on environmental projects. And she said, you know, I can give you the money. That's not a problem. but are you sure that this is the better than some of the other things that we would do with the money? And you know, I lost sleep over that question. I went back and thought, wow, you know, there's a lot of good products. There's a lot of good things happening. Is it right for me to take this money away from those other programs because I'm environmental? And it really bothered me, because now, you know, I had to know what everyone was doing. I had to know which was the best, and I had to know if it was justified to take the money away from these other programs and put it in just an environmental program that was going to take 10 years on the investment, because there's not unlimited money in a business. And so that's kind of where I'm coming from on this presentation today, is some of the things I've had to learn. So what I want to do is I want to talk about reduce, reuse, and recycle. And I want to do that in the reverse order. I'll first talk about recycling and just share with you some of the things that I've learned as an environmental engineer at a manufacturing company. I think you'll find some of these kind of interesting. Okay, so the first thing I want to talk about is this recycling. And when I first started, we got our first facilities ISO 14001 certified back in the late 90s. And I had all these teams helping me work on these environmental issues. However, the teams were all about recycling. As part of ISO 14001, you have to set goals, and you have to show improvement and achieve your goals. And I noticed that all the facilities had goals to recycle. And after a few years of still seeing goals to recycle white paper, I was ready to scream. There's got to be something better than you know, having goals to recycle, because you should already be doing that, for one. And second of all, there's a lot more important things to spend your time on. And so I want to try to help educate you in the way that I was educated. And maybe you already know this stuff, I don't know. But I want to talk to you about life cycle assessments. Because as the environmental engineer for the facility, people would ask me, well, what should we do? Should we do this or this? Which is better? And I found out that even going to the grocery store and they say, do you want paper or plastic? I don't know. That's a big question. What should I say? You know, you want to ask somebody for some help just answering that question at the grocery store. Now here I am trying to answer that question for a large manufacturing company. And so what I want to do is just use that plastic or paper example to kind of show you the process that you have to go through before you can answer the question, plastic or paper. So, I mean, let me just ask you. You're at the grocery store and they ask paper or plastic. What's your answer? Neither. That's right. That's the right answer. But back then, they didn't even have the neither answer wasn't even popular. But I'll tell you what. I just want you to be thinking about that for a minute, paper or plastic, because, and I know you're going to say neither. That's the right answer. But just for this exercise, let's go through that process, because in a manufacturing setting, you can't say neither. You have to say one or the other. And so as you go through, you're going to look at several things that are required for the manufacturing of these plastic and paper cups. Oil. How much oil does it take to produce it? Well, if you're talking about the paper, it's 40% less oil than the plastic. Oh, well then let's use plastic. But wait a minute, not so quick. Don't jump to conclusions. Paper uses 15 times as many chemicals as the plastic. Oh, okay. What about electricity? 13 times more. What about cleaning water? 30% less. That's good. Process water, 170 times more. Steam, 6 times more. Okay, so what I'm showing you is that it's not an easy question. And the reason I'm talking about this is really for this next example I want to show you. Okay, so we did this with our airbags. We said, which is better? I mean, what is the impact on the environment of our inflators? And so we went into all the categories that you can look at when doing life cycle assessments, and we found that only 1% of the CO2 emissions, or the impact we have on the environment, is coming from our manufacturing. The bulk of it is coming from the people driving the cars based on the weight of that part, and that part going thousands of miles around the country. So, back to my original situation where I'm asking for money. I need money to do environmental projects. Is my money going to come out of the pocket that could pay to reduce the weight of an inflator? Because if it is, I shouldn't take the money. I should let it go to reduce the weight of the inflator, because it's going to make a much bigger impact than if I do it myself, if I do my environmental program that I wanted to do. Interesting. So I found myself in a situation where, you know, I want to, anytime anybody asks me a question, I wanted to say, well, it depends, because I need to buy myself time to get an education before I can answer the question. And sometimes the answer is not all that obvious. So anyway, when it comes, now I want to move on and talk a little bit about reuse, and just share some examples with you, and kind of just share my experiences with you that I've had in environmental engineering. It's kind of interesting. This right here, this machine, I'll use the laser pointer to point out some things. This machine right here, these are curtain airbags that cars have to protect your head in a rollover accident. And this machine is designed to build these. It's fully adjustable, so it's ergonomic for the workers. And this machine here is state of the art. These machines cost hundreds of thousands of dollars. And when many years ago at Autoliv, I would go by the outside of the building, and I would see tons of machines like this stored outside while they're waiting to be scrapped for metal. Yeah, we were recycling them, but I got to tell you, that was not the best option for these machines. We found some problems. We've been building these machines and the tooling for their production lines by going with the lowest bidder and going with different bidders and whoever could do it. We found that it was very hard to reuse these machines, because the way that we saved some money going with the lowest bidder. And these machines have light curtains on them. They have everything you can imagine. Printers. They have scanners, readers, fully adjustable, like I said. So these machines are very expensive to build, and we were not doing a good job of reusing them because of the way that they were built. And we tried to save the money up front by going with the lowest bidder. We made some changes. We started standardizing these parts so that we could reuse them. And we started another process of assigning where that machine would go after it was end of life. So what I want to do in this example is I just want to talk about the system that we have and how we overcame some of these hurdles that kept us from reusing these really expensive machines. So the question is, what happens at the end when production ends? What we changed it to after we standardized them, is that the end of production tooling and machines, it gets posted on a board. And I'll just kind of go through this fast. And then the launch group for the new product has to review this before they can, it's part of their checklist, and have to review it to see what tools or machines are going to be retired. And they have to look at them to see if they can reuse them. And then they claim it with a ticket. They put it on the board and say, even though these are a couple years in advance, they're saying, hey, at the end of the life of this tool, I can use it, and they put a claim on it. And and then the tooling machines are assigned to new programs. Some of the advantages of this and some of the results are that on this one example that I was looking at, they were able to reuse 12 out of 12 machines. And I mean, at hundreds of thousands of dollars, it's saving a lot of money. It costs us a little bit more to standardize, and we build them in-house now, but it saves us tremendous amount of money down the road. And it comes out to the point where it's actually about $1 per part. In the time of this slide, they were making 450,000 parts a week at $1 a part. You can just see how much money it saves. Now we're making more like over 600,000 parts a week at this facility. So anyway, that just one example of the advantages of reuse. I'm not saying this is the example that everybody can take home, but thinking about reusing some of the principles of standardizing, everybody can take that home and pay a little bit more up front and save a lot in the future, as well as reducing your carbon footprint. Next, I want to talk about reduce. This is where I want to spend the bulk of my clout, because this is where it's at. What we've done, and this, just back to my example where I wanted to use the money for an environmental project, and I looked at where the money was coming from. This is where the bulk of our money goes, is to reduce. And I didn't even know it, because it's not done through the environmental department. It's done through our production. And let me just show you some of the things that we've accomplished. First of all, the way we've done it is through lean manufacturing. We had a gentleman from Toyota come and live with us for 3 years and teach us the Toyota production system. And you would not believe the results. I'm going to show them to you in a minute, but it's just, this is the reduce part of the 3 R's, and it's fantastic. The numbers, you know, money is the language of management. The numbers show this is the right thing to do. Okay, I just wanted, if we're going to be talking about lean manufacturing, I need to just briefly mention a couple of things. Oh my word, I didn't know that this was hooked up. I didn't do that, so I got these slides from someone else. That would drive you nuts if I left that on there. Matter of fact, I think I'll just click through these because I can hear it up here and it's driving me nuts. I'm just going to show these to you and maybe just mention a couple of them. Okay, waiting. So the Toyota, the lean manufacturing gets rid of 7 different wastes, and this is what they are: waiting, delay. At Autoliv, we really were, before we started lean manufacturing, we did a really good job of preparing for just in case before we went to just in time. We had warehouses full of things like explosives and you know, things like that you might need at a later time. And when we went to this lean manufacturing, we found all these warehouses that we didn't need anymore, because it's just in time does it so much better. And the problem we ran out to a lot of times is we'd fill up our warehouses, and then we'd find out that we didn't want that stuff anymore. It's kind of like at home, you know, out in your garage, you got that stuff that just sits there year after year. You don't want to throw it away because it has value, but it stays and it stays. And anyway, we were guilty of that on a large scale. So with this lean manufacturing, we went to just in time, and all of a sudden ended up with all these empty warehouses. Overproduction. I just can't tell you how many times we spent good money producing all these parts, and then decided that we needed to throw them away because they didn't meet our quality or our production demands. And that used to frustrate the living daylights out of me. We'd be throwing away good parts that were no longer needed. And then you paid to produce them, now you're paying to throw them away, and it's not good for the environment. So then rework production defective parts. A lot of people say, well, if it costs $10 to make a part, you make a bad one, you throw it away, you grab a new one, it's only going to cost you $10. That's not right. In manufacturing, if you have to remake a part because of the fact that you have to identify a bad part, you have to handle that bad part, it's going to cost you 3 times as much to make a bad part. And I'll show you some numbers in a minute about where we've gone over the years with making bad parts. Motion, unnecessary motion, I'll show you a slide on that also. And we already talked a lot about inventory and storing stuff in a warehouse, which is all waste and doesn't leave you response time to make changes when changes are necessary. You have to go back and rework everything if you're gonna salvage it. And so reduce is where it's at. Okay, let me just kind of share some examples of what happened to us when we became lean. When we became a lean manufacturing company. So our sales of units went up 51%. Now that was because of the market, not because of what we were doing. But our revenue went down over this time. So if your revenue is going down and your sales are going up, you're losing money, right? No, we actually increased our operating income over 250%. And I'll show you, I want to show you some slides that show this. So back in '93, when we were building inflators, we would build per person, we were building, about 2,000 inflators. Okay, we got better every year. We did more. Look at where we're at now. I'm sure we're even above 35,000 parts per person. That's a lot of profit. That's a lot of money to pay our wages and to pay bonuses and to take home and buy new cars and perpetuate our industry. But anyway, so there's one example. And, I wanted to show you the example of what happened with lean manufacturing. That was a huge jump. And I remember thinking, man, we're probably about there. How much more could we do? And then we went with lean manufacturing, and it skyrocketed. I'll show you some more slides. So here's our square footage in for a driver's cell. That's a driver inflator. And here's what happened with lean manufacturing. We reduced the real estate that it takes to produce those parts. 85.5% improvement. That's unreal. Producing with, now we can use the same buildings instead of having to build new buildings, instead of having to heat and cool new areas, we were able to produce in a much smaller area. Here's another example on customer returns. This is huge. Producing about, in 2008, 4 bad parts per million. If you could get anywhere close to that at the doctor's office, this world would be a much safer place. I don't know what their bad parts, their mistakes per parts per million are, but it's way safer to have an airbag inflator in your car. Next, this is just another slide that shows the same thing, but I just wanted to show you how fast it was dropping during this time. It was just falling from lean manufacturing practices. They have some things where you stop the line when you're making a bad part. If a bad part comes out, you stop it. You don't make bad parts. You stop the line, and it gets fixed right away. So some very cool things with this lean manufacturing. Now I will say this. I want you to see this slide here. This is the energy that it takes to run one of our facilities. And I just want to use it as an example because, I was worried about trying to take some of the money away from production to use it in saving some energy. And then you look at how much energy our production people were saving with lean manufacturing. It was huge. American energy use is 31% of the energy in the United States is used for industrial sources, 28% for transportation, 23% for residential, and 19% commercial other. this is huge, but you know, I realized that the best thing for the environment would be to shut our doors and not produce. That's not an option. But I'll tell you, one option we do have is to reduce, and that is a big hitter. I mean, if you look at these percentages here that happened at our facility, when you're comparing the energy used per parts produced, it's huge. And right now, the U.S. Department of Energy has asked manufacturers using the Better Buildings, Better Plants program to reduce your energy use by 25% over the next 10 years. Easy, easy. We can do that in the next, 4 years with the practices that we're using with lean manufacturing. So this reduce using lean manufacturing is awesome. Okay, but I do want to put in one warning associated with lean manufacturing. You know, you can employ some of the principles of cutting out waste, but if you're gonna use lean manufacturing, you really need to have it come from the top down. You have to have management support. During the early days of implementing lean manufacturing at Autoliv, we got very frustrated with some of the things that it required you to do, like making shadow boards. Does anybody use shadow boards? I mean, I try to use them at home in my garage to keep track of my screwdrivers. But if you try to do lean manufacturing and you don't have management support, it's a long road and it's a frustrating road. So I just wanted to put that caution in there. Okay, so I wanted to come back. I showed you that in the early days of our ISO 14001, our facilities all had goals to recycle. So I thought it only fair that I throw up the goals from last year at our facilities. These 3 facilities are some of my pride and joys because they're goals. But they're in Mexico, all 3 of them. And just look at their goals. Reduce, 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 reduce. I mean, and then when they do, there was a recycling of pens, something new that they hadn't done before. So there is still a recycling, but I'm just so impressed at what these facilities are accomplishing. It's amazing. All right, so let me just summarize that reduce, reuse, and recycle. As we look at these things, they're all not equal. We need to, like was said earlier with the plastic and the paper, we need to not, the goal isn't to recycle, the goal is to not produce the stuff anyway. Okay, any questions? Nicole, this is not, I mean, I know Nicole, but I didn't ask her to ask this question. So her question is, she knows that at Autoliv we've been offering lean manufacturing training, and yes, they're still doing that. That program is live and well. It's died down a lot because so many people are doing it now. But if anybody's interested in that, just come up to me afterwards, and I'd be happy to give you a phone number because we do. Autoliv decided that we had a good thing going. It's kind of interesting with lean manufacturing. They don't really try to, it's not proprietary so much. I mean, the gentleman from Toyota came and lived with us for 3 years to teach us that at Toyota's expense. And we don't just use it for manufacturing Toyota parts, we use it for manufacturing all parts. The benefit to Toyota, though, was that the price of airbag inflators has dropped tremendously. And so they're saving money, but so are all their competitors. But the industry is where it is really benefiting from it. Thank you. Any other questions? All right, thank you very much.